This video, and here it is. Start with the integumentary system. And remember, the integumentary system covers the skin, the hair, your nails, sweat glands, and sebaceous or oil glands. So skin has two distinct regions, an upper or superficial region, called the epidermis, which is an epithelial tissue that is avascular. It is a stratified squamous epithelium. Below that is the dermis, mostly fibrous connective tissue that is vascular. That's where the nutrients come from that provide nutrition to the lower layer of the epidermis. And then, as I was telling you on Tuesday, the subcutaneous layer is just below the skin. It's really not part of the skin. It shares some of the skin functions. It's a lot of adipose tissue absorbing shock and insulating, and it also anchors skin to the underlying structures, in most cases muscles. So here's our image of skin, and you have the image in your book, and I suggest you go through your book, take a close look at it. The layers we're talking about are the epidermis, the dermis, and then in the dermis is two layers. These are the papillary regions, edges. Apologize for my cat. So let's start with the epidermis. The epidermis consists of keratinized stratified squamous epithelium, mostly. There are 4 cell types found in there. The most numerous of those are the keratinocytes, which produce a fibrous protein called keratin, and that keratin provides much of the protective properties of the skin. They are tightly connected to one another by a junction known as a desmosome that we saw a few weeks ago when we talked about cell-cell junctions. But we lose about 40 million of these per hour, so we lose millions of cells a day off the surface of our skin, although they are dead cells by the time they get to that point. We also have melanocytes here. Those are kind of spider-shaped cells that are located in the deeper parts of the epidermis, close to where there is blood vessel supply for nutrients. They produce a pigment called melanin. That melanin is packaged into a vesicle that's called a melanosome. And the melanosomes are transferred to the keratinocytes. And the keratinocytes use that pigmented vacuole to cover up their nucleus and protect the nucleus from damaging damaging ultraviolet light. In addition to that, we have dendritic cells, which are called Langerhans cells. Traditionally, they are star-shaped macrophages patrolling deep in the epidermis, key activators of the immune system. Tactile, traditionally known as Merkel cells, after the anatomist who described them, which contain sensory receptors that sense light touch. Epidermis is made up of either 4 or 5 layers of these stratified squamous epithelium, the keratinocytes. In almost everywhere it is 4 layers, but thick skin, which we find in our high abrasion areas like our hands and feet, does have a 5th layer just before you get to the top. So the 5 possible layers are stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. And it is the stratum lucidum that is only found in thick skin. The stratum basale, the basal layer, is the deepest. That's called the base layer in Latin. It's firmly attached to the dermis, contains a single row of stem cells. Those stem cells, skin stem cells or epithelial keratinocyte stem cells, divide very often, and they produce 2 daughter cells. One of those daughter cells will differentiate, become a keratinocyte, and make its way to the surface of the skin. The other daughter cell is going to stay there in the stratum basale and be a stem cell. So this layer is also sometimes referred to as the stratum germinatum because it's where active mitosis or germination is occurring. About 10 to 25% of that layer is also melanocytes that produce the melanin for us. Just above that is the stratum spinosum, and the cells look kind of prickly here, and that's where the name comes from. It's several cell layers thick, so when we say a layer of epidermis, we don't mean one single layer of cells in most cases. Cells here have a web-like system of intermediate pre-keratin filaments attached to the desmosomes, which allows them to resist tension and pulling. Keratinocytes here appear spiky, so they are called prickle cells, stratum spinosum. And scattered among those keratinocytes are more melanosomes and dendritic cells. Above that is the stratum granulosum, literally the granular layer, which is 4 to 6 cells thick, but the cells are flattened, so the layer itself is very thin. Cells change their appearance here. They become flattened. Their nuclei and organelles disintegrate. The process of keratinization begins, which simply means that the cells are accumulating keratohyalin granules that help them form keratin fibers as they continue their journey upwards. Cells also accumulate laminar granules, which is a water-resistant glycolipid that slows water loss. And any cells above this layer are too far away from a nutrient source to remain alive, so the cells above the stratum granulosum are dead. The stratum lucidum, if we happen to be in thick skin, is a thin, translucent band of 2 or 3 rows of clear, flat, dead keratinocytes, and it's would be just above the stratum granulosum. But in most cases, we would not have the stratum lucidum, and we would go right to the stratum corneum, which is also called the horny layer. Here we have 20 to 30 rows of flat, anucleated, keratinized dead cells, about 3/4 of the epidermis thickness. Even though these cells are dead, they are the ones that provide the bulk of our protective function. They protect the deeper cells from the environment, they prevent water loss, help protect from abrasion and penetration, and they are very good barriers against biological, chemical, and physical assaults. The cells change by going through apoptosis, so those dead cells slough off and become what we would refer to as dander or dandruff, and we shed about 50,000 cells every minute. I think I said 40,000 every hour a little while ago. We shed a lot of cells over the course of a day. And here again is an image, then I would recommend you go to your book and look at that image, look at it closely, read it. In the textbook, images are just as important as the words. Then we have the dermis. Below the epidermis is a strong, flexible connective tissue. Here the cells would include fibroblasts, macrophages, mast cells, white blood cells. There are fibers in the matrix that bind the body together. This is what makes up the hide. This is what we would use in other organisms when we make leather. It contains nerves, blood vessels, lymphatic vessels. Here we have the epidermal hair follicles, the oil glands, and the sweat glands. It's going to be divided into 2 layers, the papillary layer and the reticular layer. Here's an image of it. So here we have the papillary layer, and then below that the reticular. And you can see the difference in staining patterns between this lighter blue and these darker orange collagen fibers. And you see the papillary layer moves up into the epidermis in what appeared to the first anatomist as the wings of a butterfly, and that's actually where the name papillary comes from. So that superficial layer of areolar connective tissue is loose, interlacing collagen and elastic fibers along with blood vessels. Those loose fibers allow phagocytes, like macrophages, to patrol for microorganisms. And those indentations into the epidermis are called the dermal papillae. They are the superficial regions that form projections. Those projections are where we find capillary loops, free nerve endings, and touch receptors. Those are called tactile corpuscles correctly. but they are traditionally referred to as Meissner's corpuscles after the anatomist who first described them. In thick skin, the dermal papillae lie on top of the dermal ridges, and that gives rise to the epidermal ridges, which we are known as friction ridges on the surface that help us grip and contribute to our sense of touch. And they have sweat pores in the ridges, and those sweat pores, when we sweat, are what leave behind our unique fingerprint patterns. The reticular layer, which makes up about 80% of the dermal thickness, consists of coarse, dense connective tissue, many elastic fibers providing stretch and recoil properties, collagen fibers that provide strength and resiliency. The collagen helps to bind water and keep skin hydrated. The cutaneous plexus is a network of blood vessels between the reticular layer and the hypodermis, and the extracellular matrix has pockets of adipose cells or fat cells. Cleavage or tension lines in the reticular layer are caused by many of the collagen fibers running parallel to the skin surface. We can't see these externally, but surgeons know their approximate location, and they're going to use those to guide where they make incisions, because if you cut parallel to a cleavage line, you get a less scarring form of healing. So here are those dermal modifications resulting in characteristic skin markings, cleavage lines in particular. The reticular layer has flexure lines. The reticular layer are the dermal folds near joints. The dermis is tightly secured to deeper structures. The skin's inability to slide easily for joint movement causes deep creases. We can see these on places where we bend a lot, like our hands, our wrists, our fingers, our soles, and the toes of our feet. You can still see your soles of feet and toes. So markings here are these flexure lines. So extreme stretching can cause dermal tears, leaving us silvery white scars that are called striae, more commonly referred to as stretch marks. Acute short-term traumas to the skin can cause blisters, which are fluid-filled packets that separate the epidermal and dermal layers. And this next image is an image of one of the bravest people I have never met. Any woman who would have a picture of her stretch marks taken is very brave in my book. My wife would not have posed for this picture. Skin color comes from three major pigments. Melanin, which is the only pigment actually made in the skin. It's made by those melanocytes. It's made from amino acid tyrosine and tyrosinase, a very modified form of tyrosine, packaged into melanosomes that are sent to shield the DNA of keratinocytes from damaging ultraviolet light. More sun, the more you need the protective shield, the more melanin will be produced. There are a couple of forms of melanin. One is a reddish yellow, the other a brownish black. And skin colors differences are usually due to the amount and type of melanin formed, not the number of melanocytes. Freckles and pigmented moles are local accumulations of that melanin. Excessive sun exposure causes damage to the skin. The elastic fibers clump, causing the skin to become more leathery. It can also affect the immune system, alter DNA that might lead to skin cancer. Ultraviolet light destroys folic acid. Folic acid is necessary for DNA synthesis, so it's especially dangerous for developing embryos. Photosensitivity is an increased reaction to the sun, and there are some drugs that can cause photosensitivity. Perfume can cause photosensitivity in some individuals and lead to skin rashes. Carotene is another pigment. It's a yellow to orange pigment. It is most obvious in the palms of our hands and soles of our feet, but it accumulates in the stratum corneum and the hypodermis. Can be converted to vitamin A for vision and help with our epidermal health. Plants are a good source of it. Hemoglobin is the component of blood that is carrying oxygen. It has a shade of red to it, depending on whether it has oxygen attached or not. And because Caucasians have less melanin, it is easier to see the effects of hemoglobin on skin color. So excessive exposure to the sun can cause going the wrong direction in your slideshow. So clinical homeostatic imbalances in skin color. Cyanosis is a bluish skin color, low oxygenation of hemoglobin, pallor, anemia, low blood pressure, erythemia, fever, hypertension, jaundice, again, liver. Bruises, black and blue marks, are referred to ectymoses or hematomas, a result of clotted blood just below the skin. As the clot's broken down, the color of the bruise is going to change. Some are brown or black. Hyperpigmented areas in the axillae around the neck may be a sign of an insulin resistance and elevated blood glucose levels. And I will stop there and pick up the next set of lectures, next videos from this point.